Hi, I'm Bob Warfield from CNC Cookbook, and today I want to talk about the value of fixtures. There's an old saying in the machine shop world that the real money is made from having great fixturing. If you're good at making fixtures that save time, you'll turn a bigger profit, in other words. But is it really true? Does every job benefit from fancy fixturing? Let's dig in and find out. If we look at the various ways fixtures can reduce costs, we see these kinds of things. The right fixtures reduce setup time. If you can drop a fixture right on with a fixture plate, you'll save the time you'd spend tramming the fixture. It winds up at a repeatable location. You may not have to set part zero either. That's definitely going to result in reduced setup time. You may reduce the time to load a raw workpiece and the time to unload parts. Particularly, you may move that time to a point where the spindle is running concurrently. For example, with pallets, most of the loading and unloading can happen while the machine is running. Here's another way to reduce costs. Fixtures can often allow greater part density. That means more parts per run. Since more parts are being made in a single cycle, the cycle takes longer. So, the machine operator may be able to tend to more machines or perform other valuable tasks during the longer cycle times. You may even choose to run those long cycle times as part of a lights out sequence after the end of the shift. If you're running more parts per tool setup, you can program the job so each tool change takes care of every part before the next tool change. The value there is fewer tool changes over the course of making a given number of parts. All this adds up to reduced machine idle time and moving jobs more quickly through your shop. That can mean you need fewer machines and fewer employees to get a given volume of business done. But here's the big question: do you always need fixtures? As good as they often are, they may not always be the right answer. There are costs associated with any fixture, the time to build the fixture, and the components and materials that go into it. The right answer is you should use a fixture whenever the savings exceed the cost of the fixture. Here at CNC Cookbook, we've created a fixture calculator that makes it easy to determine that trade-off. We'll be using CNC Cookbook's fixture calculator to find the return on investment of various fixturing scenarios. I'll demo that shortly so you can get a sense of the ROI of fixtures and also know how to run the fixture calculator. Our fixture calculator is on our website, and I'll give the link to it at the end of this video so you can work through your own examples to find fixture return on investment. Be sure to keep watching so you don't miss that link. Okay, let's check it out. Here's our free fixture calculator on the CNC Cookbook website. As I mentioned, I'll give you the link at the end of this video. Let's take a quick walkthrough and do a few example calculations. There are some options here along the top for what happens before we have the fixture set up on the machine. We maybe want to use a fixture plate to reduce the setup time. These help a lot, and you can find another CNC Chef video here on cutting tool engineering to learn more. Is this a repeat run where we don't have to build the fixture? Again, that's even more savings. Do you have a CNC machine with a pallet changer for even quicker setup and loading? Now, as you can see, there are two columns for fixture A and fixture B. They represent two scenarios you want to compare to find a cost savings. Probably the best way to understand how it works is to dive in and start with a simple example. Suppose we have an order to make 5,000 of a particular part, and we have a choice. We can use two vices on the machine to make 2 parts per cycle, or we can build a custom fixture that can do 8 parts per cycle. Let's go through and check the return on investment if we were to build the 8-part fixture. Okay, first we have to account for the time it takes to build the fixture. Let's say it takes 8 hours. You want to be conservative on that, as this sort of thing is a one-off and will often take a little longer than you'd expect. Next, we'll put down that it takes 15 minutes to set up the fixture on the table. That means, finding the fixture, bringing it to the machine, putting it on the table, tramming it in, clamping it down, all that jazz. And we'll assume it takes the same amount of time to set up the 2 vices. Further, let's say it takes 5 minutes to load and unload the fixture each time we want to do a run of parts. Okay, and we'll use the same value for the 2 vices. Now, as I said, we can do 2 parts per run on the vices and 8 parts with our fixture. Now, let's say our CAM software tells us it takes 20 minutes to run the part. We're going to use the same value in either place. In theory, it could be shorter with 8 parts because we can set up to change tools once for each of the 8 parts. But for now, let's just keep it simple and assume they both take 20 minutes. Okay? Now, we have the total run time to make the parts, right? 40 minutes versus 160 minutes with a fixture. Much longer cycle time. By the way, remember, just increasing the cycle time could be valuable because it gives the operator time to do something else, or it might be the perfect thing to let it run lights out at the end of a shift. Okay? Now, we said we wanted to make 5,000 parts, so let's go ahead and tee that up. 5,000 on each scenario. All right. Got that taken care of. Now let's see how much time we save. We're going to be making 2,500 runs with the 2 vices versus 625 with a fixture plate. Here's our total machining time, which includes the loading and unloading. We can add the setup time in there. We can add the build time in. Total time the operator spends loading and unloading. And wow, here's our total time savings. 18,270 minutes. That's like 300 hours of time saved by building that fixture. To get an idea of what the value of that is, if our shop has an $80 an hour billing rate, that's $24,000 right there, folks. That is a big saving, and that's why we like fixtures. It was really worth it to build one for this job. So let's check another scenario, right? We live in a time of high mix, low volume orders. Everybody wants just-in-time inventory. So maybe we're not getting orders for 5,000 parts. Maybe instead, we're only going to make 500 of the same part for this job. What does that savings look like? Well, it's much less, a little under $2,000, but that still means we should make our fixture. Okay, what about if the customer only wants 100 parts? I think you can see where this is probably going. At 100 parts, we're actually going to lose $250 if we stop to make a fixture. For that low volume order, in this particular case, we should just slap the vices on the table and let them rock. And we'll get done just that much sooner. Matter of fact, maybe we've got dual station vices and we can do 4 parts a run here with our vices. In which case it's even more bleak for building a custom fixture. Okay? So I think you can get an idea from this that it doesn't always make sense to build a fixture. What you want to do is actually do the math, use a fixture calculator, figure out the ROI, be conservative on your numbers, and take a look. Now, it may still be worth it to build a fixture for these small volumes if we're really confident in repeat orders. So keep that in mind as well. But that's the story on when to build a fixture and what the return on investment can be for it. Okay? All right, I promised I'd give you that link. Here it is, www.cnccookbook.com. Fixture Design Fundamental. That's where you'll find our free fixture calculator. Thanks for listening. I'll be back soon with another CNC Chef video for you.